Hello and good evening, and welcome to tonight's Journal Club. Tonight it's going to be Rick Alling talking about our poster for the conference in Australia, the Isaac Conference in Australia. So, Rick, take it away.
Hey, thank you. Thank you. Yeah, so we had one of our sort of like get-togethers about a week or so ago, and Chris was like saying, "Oh, what about Journal Club? Should we suspend for the summer? We want to keep it going and all this stuff." And so anyway, I volunteered to talk a little bit about some of the stuff we're working on right now because it's really got me energized. It's got us going. We've got a lot going on. So aside from what Greg just mentioned is that several of us, Greg and myself, and then Mary Wiaki, our Native American consultant, we're all heading for Australia this weekend. So, then we're going to join a cultural astronomy class for about 3 days, and then we get a day off, and then we're in a conference, the Isaac Conference, for 5 days. Mary's doing a full presentation. We're doing a poster. You're going to see that poster tonight and give us advice, and you can critique it. And then also, I have some colleagues. Well, you might know Karen Neerman is one of our board members. Karen is a professor at ASU. Her husband is Patrick. They are also going because Patrick and Karen and I kind of co-authored a course on cultural astronomy for ASU about 3 years ago, and we're redeveloping and reimagining and adding new content. But we're going to relaunch that course, we hope, in the fall. No, I'm sorry, in the spring. So anyway, so they're there and presenting a poster. So there's a lot of us representing the society in Australia, and we're really looking forward to it. Aside from that, there's been a lot of field work and some stuff and some all kinds of stuff going on. So let me just get started. I am going to share with, oh, go ahead, Evelyn. Did you have a question?
I just wondered if you'd ever been there before. It's
Never have. I have never
oh,
been south of the equator, in fact.
oh
And
wow.
I
You're gonna
hear that
love
there,
it.
No,
I hear
I
that there,
haven't been to Australia either. I don't think Mary has. I've been south of the equator a couple of times, in Peru and that, but the sky was always too junk, and Argentina, but the sky was always too junky to see anything. So.
uh, so I hear there are stars down there that I've probably never seen before.
You're
So,
right.
so here I go. I've been a
And
stargazer all my life, and I get at the age of almost 67, I can actually go look at new stars. So,
and I actually enjoyed the Milky Way because there's dark clouds. It's very
right,
different. And well, I
absolutely.
enjoyed a lot, but I my sister lives there, so I'm lucky. Been there
Yeah.
7 times.
Oh, wow. Yeah.
I'd go again in an instant. It's great.
Hey,
William, do you have a comment? Been there?
Rick, Rick, I didn't catch the name of, the class and where you're gonna be teaching. What is that again?
So, oh, I'm sorry. So, two different things. In Australia, we're attending a cultural astronomy class. It's 3 days and it's associated with the conference. The other thing that I'm working with professors Patrick Young and Karen Neerman, that's at Arizona State University. And we did that as a, like I say, we put together this as a course. And the unique thing about it is that it follows or it is inspired by a art exhibition at a local museum called the Heard Museum, which is one of America's preeminent Native American museums.
international.
They hired a curator to put together a program, whole exhibit called Substance of Stars, and it features four different tribes in the United States, and it's permanent. So tribes will, roll out, and new ones will come in, and so we're very excited to be part of that project and start it. And then we turned it into a course, essentially, about cultural
So
astronomy as well.
is it a, is it a course in archaeoastronomy?
It is, yeah, cultural astronomy, as we would say.
Okay,
Yeah.
okay.
So, mhm.
So you're aware that there are others that are also attempting to develop a course along similar lines, including Steve and
Yeah,
Fabio and so on. Yeah.
I know Steve has, and I know in various ways it would be interesting to sort of almost have like some sort of little seminar on just that. Those that teach cultural astronomy. We will learn a little bit about that in Australia, thankfully, but it's very ad hoc, and there is no sort of cookbook that says teach cultural astronomy this way. And so I think people are sort of just feeling it out. And ultimately, best practices will be found.
Well, one other quick question. When you set this up at Arizona, will this be a credit course, or can anybody sign up, or how's that?
I see. It is a 4-credit course, and but I will, when I get the details. It hasn't been announced yet, and hopefully it will launch as if people can register in October, this coming October. And we're waiting on some material. There was a lot of video work that the curator of that exhibition was doing with individual tribal members, and that has been taking a long time to roll out. So we were kind of on hold waiting for that to happen. We expect it all to release, but I'll make sure that you know about it.
Well, you got at least one attendee.
There you
got
go.
at least one attendee.
Yeah, there you go. Sounds good.
Real quick, just to kind of clarify for William, they actually call it a school before the conference.
Yeah.
Okay.
And they had a school at La Plata 3 years ago before the conference. So it's, they're trying to teach. Now, here's a book. I don't know if y'all can see this.
Got to hold it in front of your face.
All right. How's that?
You disappeared. Nope.
No, man.
Yeah, no, we're not going to be able to read it.
Anyway, this is by Giulio Maglia. And it's Archaeoastronomy, Introduction to the Science of Stars and Stones. It's a Springer book, undergraduate lecture notes in physics.
We got it.
Okay, I just wanted to.
Thanks. Yeah, thanks. Yeah, it's a pretty good book. Yeah, it's good.
Yeah, I have that one too. Oh no, here's another one that you guys should probably look at if you're interested in such. Power of Stars.
Yep.
It's also Springer, Brian Penpraise, and it is written like a textbook about cultural astronomy. And so anyway, both of those are sort of super cool. Can you drop Gordon? Can you just write that into the chat? Just what the name and author is?
Okay, sure. Yeah.
All right. That's not what we're going to talk about. You guys ready to start?
You bet.
Okay. So let me just share this with you. So this is actually the poster. And I think I probably have to get rid of some of this stuff or you're not going to see it very well. Can everybody see that fairly clearly?
Well, yeah, there it is. Okay.
So essentially, this is it. It's Greg. It's made some improvements since you saw it last. It's 90% there. We still have some more proofing to do, but this is essentially what we're presenting in Australia, and it covers a lot of the practical processes and analytics that we do when we do this cultural landscape survey program. And so I wanted to kind of start with this. We'll end with it. I'm just going to pull it apart. You're going to see in the PowerPoint, we're just going to pull this whole thing apart and talk about the individual elements, how they roll out together, why they're important, and what we've learned along the way. And stop me anytime if you have a question. Greg, feel free to sort of add in if I need to sort of dwell on something if it's not clear. But this is essentially what we're presenting and how we're presenting it when we get to Australia. You'll see here that I've got basically the survey program divided into those 3 bands across it. Basically field operations, data processing, and the products, some of the derivative products we have. There's a lot that isn't on here. This is crowded and there's a lot of information here, but there's also still some stuff going on. For example, I don't hear talk about pre-planning. Why do we pick what sites? What sites are available to us? What kind of stuff goes into planning before we even get out to a site? I haven't covered that here. That's maybe the subject of another thing, but I'm going to kind of cover this. Right under that banner where it says Envisioning Cultural Landscape is a paragraph, and that kind of encapsulates everything, and I've summarized it for you. So this is essentially what this means. What we're trying to do here is basically, as you can read, I don't want to read it to you, but we're basically standardizing a recording process. And it goes beyond sort of the normal archaeological dig recording. That's important. We're developing a repeatable process. It's process oriented. And then there are documents that are part of the output, and we want to shape those so that they're not only important now as a product of our work, but also have lasting work. I'm imagining 5, 10, 20 years from now, people are pulling our documents up and using them, which would be kind of cool. Let me just sort of sort of enhance this a little bit. So going beyond the recording already done in field archaeology, we're not replacing it. We're not trying to be archaeologists. We're basically saying they have their role, they do what they do in the field, and then we sort of add to it. It is an enhancement. It just basically takes landscape and push it, and as I said here, push the boundaries of the site out to the horizon. Greg and I always use the example is when an archaeologist approaches a dig site, they first draw a boundary around it, and then they dig inside the boundary. We say that that's only part of the story. There's another artifact on board here, and that is essentially their placement and the landscape as it is. So anyway, that's kind of where we live. We're also, this is important. We want this to be repeatable, and we want it to be process oriented. So we're trying to, as we work through these projects, and you'll see we've got experience in about 3 different sites. We're trying to every time just sort of like, just make sure that we've got the process down. We do it in the right order. We do it the right way. We have a little bit of the integrity of our data is captured, and we have ways to do that and that kind of thing. So it really is sort of something we expect to happen over and over again. And so that's a workflow, and then it's teachable. I think my thing might be in a way. Is that better?
No, that's fine.
Is that all right? You can see the whole slide. I just have my one. So anyway, this is it. It wants to be teachable. We want to get others to use it, and I might talk more about that a little bit later. And then finally, I wanted to sort of add that this is there is an output. So there's documents that can become part of an archaeological site report. And so we'd like to be able to partner, or not partner, but be adjunct to an archaeologist of record and say, here's the part we can provide for you. And then those documents get added to the site report, and then it sort of becomes part of the thing. But we also understand that there are essentially 3D things that we do. There's data that we do. There's things that can't be reported on paper. And so we're engaged in the process of trying to organize that and understand how are we going to preserve those files and those records so that people can use them in the future. And then it's my hope, I love statistics. I absolutely love statistics. And we've visited exactly 5 places, and there are thousands and thousands and thousands of places to be documented. So it's my hope that sort of as in the long run, there becomes enough data measured the same way that it becomes statistically, analyzable, that it is sort of like organized so that it can sort of bring out information that we couldn't otherwise do. And so all of our sort of output work is kind of driven towards that. What do we have to capture, and how do we document it? And then how does that sort of track between visits and sites and all that stuff? So that's kind of where we're at. That's how this works. That's the preamble to the thing. Here's what we visited so far. We started with Escalante Wallace Bubble. I'm not sure you guys, some of you might be familiar with that, but it's privately owned. It's, what's his name? Bradley. What's his first name? Sorry.
Chris Bradley. He's well.
Chris Bradley. And he's basically working the site. He allowed us to go and kind of like try our processes on his site. That was really great. Done some work at Lowry. You'll see that in the program tonight. Jackson Castle is very recent, and we're just in the middle. We did some field work, most of it. We're going to go back for a little piece of field work in September, and then we're writing up reports and everything by the fall. Just Jackson's Castle, and then Chris and I. Hopefully Chris will get to the meeting. Chris and I have been kind of going out to Sears Point, and I know, Evelyn, you know Sears Point, and we'll sort of talk about that later. I've got some information from Sears Point that we've been working on. All right, that's the start, and here's the poster. So now I'm going to basically take the rest of the elements of this poster and just dig in and see what's important. So here's some field work. This is essentially capturing in a couple of different ways, and each one is important, and each one kind of enhances the other. And so one of the first things we do is we get out there with paper and pencil, and we actually sort of like just measure the landscape. And, literally, you can see it in the thing here. We're drawing in across a horizon, and then we're confirming that, or at least touch pointing that with a compass, just so we get a, sort of here's features. This, I think, is vitally important because it gets us into the landscape, standing on a landscape, looking at a horizon, and having to make notes. And so I know from some of my art background and some of my museum background that actually drawing or sketching something or actually doing something adds to your brain. It adds data. It makes you look at it closer. It makes you sort of like think harder. And it's different than taking a picture. It is a sketch, and that's really how we start. We're kind of. I'll show you how that sort of ends up in the reportables, but that's kind of important. And then I'm just going to say a little note that the compass kind of gives us an accuracy of a little less than half a degree, if you want. So it's not quite there yet. So moving to the next slide, then we go ahead and transit everything. So we have picked our targets, we pick things that are of interest in the horizon that we want to capture, and then we go back and actually transit them. And we do that to get them right down to, I sort of think, 10 arc minutes. 5 arc minutes either side of an error bar is probably close enough to us. I'd like to even be better, but I think that's doable in the field. So that's kind of what we do. So we have an instrument and we do that. So we do that. And then, of course, there is photography. So this is my camera, but we sort of we've got a couple of different cameras, and we sort of landed, now that we've tried this a couple of times, we landed on trying to do this as essentially 24 frames, 15 degrees on center, and keep this camera as rigid and level as possible, and sort of do that. So we have sort of an exact recording of these, and those images, of course, overlap, and you'll see why in a minute that's important. So essentially, this is part of our field work, is sort of just capturing the space and the horizon, and capturing it in a couple of different ways with at least an idea of accuracy. We also drone sites. And this is Chris's work. He does most of the drone work. This particular image is of Escalante Pueblo. You can see it way down there below, and our little drone flying above. And so what we do is some very systematic, kind of at different levels. We cover out to a certain range. We do some pre-planning to sort of make sure we're going to cover the amount of the site, or multiple sites in some cases, that we need to cover and capture and all this stuff. And you'll see in a minute sort of how we use that. So drone work is really, really important. It gives us high fidelity images and all that. And then also in the field, this is absolutely crucial to our program. I want to mention it early, and then I'll kind of talk about it a little bit later. But we have a Native American component that goes with us. So we're in the field not only dealing with these technical things, but we're also there with trained Native observer archaeologists that also know their things to look for. And Greg and I have this experience. Mary in the case on the right, and Bertram on the left. They can point out some things to us that we just would never see. We would just walk right over it and have no idea something was there. And every single time we go out, we're sort of enlightened, and the experience is enhanced just by having that particular view of the site and that kind of stuff. And so I'm kind of cutting to the end of the paper here, the research objectives. I'll show you this again later, but I want to sort of show you, here's essentially the objectives. And the fourth one there is what I'm trying to say, is that there's the Indigenous people participation is in the process, and it's from front to back, from the design to the field work. Mary is incredible. She's been a partner all along. Hi, Chris, how are you doing? And so I'm so lucky to be able to go to Australia with her, because she really does attract a crowd. She's not afraid to speak, which is kind of fun. So it'll be good. Anyway, that's kind of that thing. So let me kind of start here. And let me move down here. So this is some of the processing work we do. So in the the left side of your screen here, this is what I was talking about, taking snapshots. These are images of the horizon and systematically taken. You can see the full file path of what those are when they get home. There's a stitching processor. I don't know if you guys have ever used it, called Huygen. And basically, it can be very easy, and it can also trigger over to very complicated if you don't have it done right. But essentially what this does is basically takes all those images and stitches it into one long panorama. And you can see that on the bottom here. I think you guys can see my arrow. So this is, again, Escalante Pueblo. And this is how we captured it. The photo stitcher basically then puts it in this particular thing. Now, not trusting that all of those images are square, or not stretched or not compressed, we take that whole panorama and essentially load it into Photoshop, where we've already established essentially a grid. In fact, I got a little detail about this. So essentially, this, you'll sort of know this, maybe you know this site. This is Sleeping Ute Mountain. And because we have the transit work, I know that that particular piece is 127 degrees. I can get it in here. And I don't just do this little bit of it. We basically cross-check the entire 360 degree thing to make sure that all of the transit points that we caught in the field during the field process are actually relevant to this particular panorama. And this is sort of what we call calibrated horizon panorama or something like that. That means that we've actually taken it and tested it and confirmed that all of these things are in place. And so I think that's a really important way to do it. So then once we have that whole panorama thingy, we can use it in various ways. One of them is to load it into a planetarium software. I like to use Starry Night Pro. Very popular in our industry and amongst ourselves is Stellarium, which is another one. And I'm going to learn a little bit more about Stellarium in Australia. I tend to like this one just because I like this one. Here's what that panorama looks like. So you can see, like over here to the east, I have Mount Hesperus. Here's that Sleeping Ute Mountain kind of thing over to the southwest. In this particular panorama, or in this particular program, then we can do any time of the day, any time of the year, and it is accurate in past years. So it deals with astronomical precession. So we can go back to 1100 AD or 300 BC or whatever. We can actually take that particular landscape and put it into an archaeological context anytime and any place. And so I think I have another image here. Yeah, so here's one that I took. So this is Mount Hesperus again right here. And this is one I sort of made for Greg. He was taking to a presentation, but you see basically the belt stars of Orion. Rigel, Betelgeuse, you sort of know this if you know your stars. And this is specifically how stars can interact with the horizon itself. And this is remarkably accurate because we've taken the time to sort of like just understand that landscape. We can load it in here and I can adjust up and down and right and left to within a couple of arc minutes within the program. But we get that nailed in exactly right. And then we can sort of like go back and replay anything. And so that's kind of a part of our process, and part of the data analysis is seeing what's available and why it's available. One of the outputs we have here, this should look a little bit familiar from the first slide, right? And now we've taken our panorama and essentially sort of just documented what we did. And this is work that Greg did. I think his name's on, well, we both recorders on this. Anyway, so this is an example of a horizon from, this is Escalante again. This is and just how much detail we can sort of like get. And on the right-hand column, I should note that we're also dealing with elevations. So the transit is not only giving us azimuth, but we're also measuring the altitude above our viewpoint. That relates to how stars are going to interact. That relates to declination. If we want to kind of create a chart that has the declinations of the mountaintops, then we can sort of like really accurately relate the stars. So that's it. In the bottom part here, the top long photographs across the bottom is a simulation from Starry Night Pro. And the bottom thing here is a image that I took of that particular landscape. And you can see how closely they match or how easily the simulation can work, because I'm using essentially the same landscape in the planetarium program as I am in the photos. So that's how it works. We're finding really great success and getting very, very. I'll show you another example of that later. The other thing, remember, we were droning, and so. And I want to introduce another thing. We rely heavily on ArcGIS Pro. It isn't part of the field work necessarily, but it certainly precedes the field work. We get to understand our landscape, what we're looking for, all of that stuff. We sort of pre-know the area we're dealing with, what it's going to look like. And in this particular case, here's an example. This is from Jackson's Castle at Canyon and Ancients National Monument. And you can see we're actually looking at two sites here. There's a major sort of Puebloan site that's called Jackson's Castle on that little arm off to the left there. And then there is a hilltop site, and we know the two relate. The architectural record does not necessarily relate the two. It mentions them separately. Jackson's Hilltop actually just got its own site number just recently. I think that's as part of our work. And so we're kind of, so I just want to just, if I can relate something about this slide, is that the amount of work we do in GIS to sort of like get the distances, the spatial relationship and everything, and the elevations right, is extensive. And ArcGIS lends a lot of tools to do that. So we do that before we go, and then during this data analysis phase. The other one sort of represents a digital elevation model, or that actually Chris is online now, so you can just chime in, Chris, and answer. Chris is our drone guy. And so we use this product called Agisoft Metashape, and that is sort of, it stitches together drone images, just like I had a program that stitched together the panorama images. You can take all of these drone images of all different places, and there are hundreds of them, and this software will kind of stitch that together and give you one cohesive sort of image of what you're looking at. Then you'll see in a later thing, some of that work can be added to ArcGIS, and so now you get a very high level digital representation on a ArcGIS model, and that's really sort of like part of our thing here. Chris, I'm going to talk about this a little bit more, but if there's anywhere you want to jump in and sort of add to it, please do. So,
okay, yeah, I will. I'll jump in.
Here's an example of this. This is what I was talking about. So you can see, I want to stress a little bit about how I think one of the magic sauce things that we are discovering, coming up with, is dealing with the huge regional scale and the intimate scale at the same time. So from the site details all the way out 30, 50, 60, 70 miles out into the horizon, and everything in between. And we're doing it simultaneously, and that's kind of, I think, important. Let me sort of give you this example here. So from Sears Point, which is, I don't know if I can zoom in on this, you can see this little red spot right up here. This is essentially this hill. So right here is what we're doing. In ArcGIS, of course, we can sort of measure bearing in degrees. Chris and I became interested in this particular peak over here called Mohawk Peak. Here's Interstate 8, right? So you can sort of see, we're talking about sort of a big area of southern Arizona. And so we pre-planned that, yes, from here, and yes, here's a site of interest because essentially of this bearing that kind of gives it a winter solstice proximity. We wanted to kind of study that. And so that's indeed what we did with this particular project. So Chris did this work. So this cover, this high detailed cover, is done by the drone flying. And I then sort of layered it onto elevation model. Sorry, didn't mean to do that. An elevation model. Hang on. And you can see, I'm going to point out this little sort of feature right here. This is a little rock. It's not very big. And you saw it earlier in the presentation. Actually, let me see if I can, I don't know if I want to take the time to go back there, but basically there's I'm going to call it a rock of interest. And this is from previously reported site visits, site work that other archaeologists have done at Sears Point. And they suggested that there are alignments, and they suggested that this rock probably has some sort of alignment of interest. And so I'm kind of showing you in this particular image that this particular line traces just like this from the rock across this little pile of stones here. That's going to be pretty important later in this presentation. And then here is essentially the peak, Mohawk Peak, that I was showing you in this particular thing. This peak is this peak. And then we went out last winter, Chris and I, and some others, and we were actually there to watch the sunset and photo image it. And so here you have essentially the sunset on December 21st, essentially, kind of using that rock as the focal point on site and the peak. There's another thing I just wanted to show you here. See how there's a little, almost like a notch here? We haven't been able to study this yet, Chris. I don't know if you've ever been up here, but this is sort of on another ridge. It's out here beyond these rocks, and it looks to me like it frames this. And I don't know yet if this has been worked or not, but it does make that particular peak more available to the site, and so I think we'll probably do that. But anyway, so I just wanted to point this out because this relationship between the drone flying and what we can capture in a site deal and what we can deal with in an ArcGIS format is, I think, really, really super important. Oh, this is the rock. I should have just gone one more slide over. So this is essentially the feature that we're trying to look at. That is this one right here. And this is my camera looking in the same direction of that sunset you see there. So that's kind of that. I'm going to leave that aside for now. This is an interesting thing we call an infographic. And infographic, I have to say, it's something that we invented as part of this project. And so, and let me tell you why I can say that with some confidence. There are other books and there are other papers and everything sort of like this just gives you that overview of a point and what looks out at the horizon and what is important about a horizon where you would have sun interactions or moon interactions with the horizon and all that stuff. In this particular case, we're actually putting the site itself in the horizon. And the horizon is true. This is exactly the same horizon I showed you before. But in this case, it's inverted. So when you put this in a planetarium software, you have all the mountains and tree things pointing inward, right? You're looking at it that way. In this particular case, we turn everything around and have all the features pointing outward. And then the arcs are meaningful. So the amber arc on either side shows you the precise movement of the sun through its cycle. And then the blue arcs sort of trace the extremes that the moon does. So the moon has extremes beyond sort of the sunrise. In fact, there's one right now, right? We're at a lunar extreme right now. And so in this area, so now we can point out features that we want to point out. And we can measure degrees. We have this axis, essentially the orientation axis of this particular pueblo, a little bit off of directly south, right? So it's about 4 degrees off. We can point out features. We can point out all that stuff. And so, but you're looking at, here's the magic here, because people would stay away from this if you were a scientist, but I say, let's go for it. You're looking at 2 different scales here. So the scale of the site itself, the pueblo itself, is huge, and it's put into a landscape. And the reason we can do this is because from the center of this image, all of this stuff works. Absolutely everybody from this site, whether they're on the outside, on the inside, on this side, on that side, they're seeing the same horizon. And this gives us a notion of what's important. The live workspace in this particular pueblo is this way, so it sort of faces the Mesa Verde range over here. This is a very important pass that sort of like goes down towards Shiprock and ultimately Chaco Canyon if you wanted to go that way. So essentially the view shed, the orientation and everything about this is captured within a horizon. Now, there's more to this. Actually, I'm going to show you another one. This is the same infographic style, but in this particular case, we've used Lowry Pueblo. And what you'll notice is that latitude is important because these particular ranges change depending on latitude. So Sears Point would have a very, very, not very different, but it would be different. We sort of, keep that accuracy. In this particular case, Greg and I were sort of like trying to make a case of what Lowry Pueblo's orientation looks at. In this case, the live workspace is to the east and facing out towards the Hesperus again, and all of this stuff. And the arcs are here. Let me just sort of like look at a little detail. So I wanted to point out this. So this is going to be where the sun essentially meets the astronomical horizon. And this is going to be the summer solstice. So here's the summer solstice. Here's the horizon that it's going to meet from Lowry Problem. Got it? And here's a little detail of that. So here's Lone Cone Mountain, and here's that. So you'll never guess, but Craig Munson actually went out, what was it, 4 days ago now? On the 21st?
Morning of the 21st.
He made his way out to Lowry Provo. He wanted to see what this looks like, and look what happened. So here is Lone Cone, and here's the sunrise right here. So just essentially, just as it's detailed out in our particular graphic, and that's essentially what's happening in reality here. So sort of like just kind of proves the thing. Now, solstices are important, but of course the rest of the thing is also important. Any dates during the year take place essentially with sun interactions to these things. So essentially, this gives us the tool to go back and explore other things. So there's oftentimes, we know from the ethnographic record that there are times of the year that things change, or moiety changes from male to female, those kinds of things. We can actually sort of like find on the horizon when these things might take place and what that solar interaction might be at that time by having a graphic like this. So we're kind of proud of this graphic, and I think we're going to be using it for a lot of different things. It doesn't matter the size of the site either. This could be just a tiny little thing that sort of then relates to this bigger horizon. So that's that part. I'm going to sort of move on. I'm almost done with this big graphic, but I want to point out a couple of other things. We added this because I like it, and Greg wrote it. So I think it. Do you want to comment about this, Greg? You have a particular reason for doing this? I think it
Yes.
kind of puts the horizon.
When I started thinking about the program itself, cultural landscapes, and documenting a cultural landscape, we have to look at it, if we're going to be able to protect it, as an object. How do you? So I wanted to try and create a documentation process that documents a landscape as an object, so that it can be, in essence, quantified in its relationship with a particular archaeological site and other sites nearby. Generally, the idea is the 1906 Antiquities Act allows for declaration and protection of objects of cultural importance. Objects is what it says. So if we created a documented cultural landscape as an object, then it is something that can be protected federally in a future administration.
Excellent. You saw this before, but it's going to remind you of what the objectives were. And like Craig was saying, is we really see this as an important aspect of an archaeological site. And we think it's been handled ad hoc, in an ad hoc manner through the history of archaeology. Some people take it very seriously, some people don't. Some people mention it in a site description, but as you can see, I think I've made the case to sort of like all the details we go through and all this stuff. We're taking that landscape and really dissecting it down to its kind of inner soul, and creating essentially a database that sort of captures the uniqueness of that landscape to that particular place and connects them together. So that's important. Here's the people that do this. And so you can see Greg and Rick and Chris are at the meeting today. So we've talked a little bit about the photogrammetry and drones a little bit, and GIS and the instruments and that kind of stuff. But Ray is also a key player. Dav Valentin has done some videography for us in the past. Mary and Bertram are Native American advisors, and so that's kind of part of the team. I think there's also Philip Tuesta. I'm going to have to add him to this and this the thing. And then finally, in the bottom of the paper or the poster, you're going to see some acknowledgments. We really, I have to say the relationship with Canyon Ancients really starts with Greg Munson, because he knows these people. He's worked with them for years. He lives in Dolores. And so Greg is our site locator, our site picker, and our site get permission to go to the site person. But he works very, very closely with Vince and Ray and the Canyon Ancients National Monument leadership. And so that's it. And then we're very, very proud and excited that we got our first grant. And so Jackson's Castle project, you saw it referenced in the poster a little bit. We got some funding. Yay! So the Historical Society gave us some money so that we could pay the hours it took to do the survey or the on-site work. We are just about to transition into the paperwork part and the data analysis part. I sort of dabbled with it a little bit, but we'll get serious about that next month after Australia and after PACOS and those kinds of things. Wanted to show you one more thing, and this is while Greg was out at Lowry doing his sort of summer solstice sunrise kind of thing, Chris and I were out at Sears Point again. So just to remind you, here's the rock, here's the camera, here's the rock. And let me just sort of try to zoom in here a little bit. Because a winter solstice sunset is essentially opposite from a summer solstice sunrise, I think everybody gets that, right? One's going to happen on that end and one's going to happen on that end. The question came up, what if we put a camera sort of out at this particular rock site? And I don't have a detail of it, but you could tell that these rocks are worked and they're pecked. And there's actually one that is kind of broken and formed into like a little seat, like you can actually go out there and sort of sit on it. And all of those are just in this little area right here. So we did this over the solstice last Friday, Saturday morning. We went out, I set up a camera just right here, sort of at the rocks over here, looking back across the rock of interest, the one that's in the image over here. And do you want to see what I found?
Sure.
Anybody want to know?
No.
I haven't even seen this yet. So.
Nobody cares about that.
Nobody cares.
So, and I can't actually make it turn, so hang on just a second. It didn't like being sort of like moved around, so hang on just a second. I can get this. What do you think?
Cool.
Yeah, that works.
Yeah, so essentially, again, you're looking at this little rock over here on the side. My camera isn't there, but essentially from that little seating area. And I also can say, I didn't bring the slide, but we did the panorama like we did in Escalante. I did load it into Starry Night Pro, the planetarium software, and I was able to simulate this. Oh, actually, I might have it right here. I have it as a photo, sorry, essentially. So if you can, this little image I'm showing you on the screen right here, you can see sort of the little notch that is the saddle. You can see essentially the ridge line. It isn't as much detail in the photo as it is in the image on the screen, but you can see this is where I have the sun rising at that particular point in a predictive kind of format by using the software. And so it did what we wanted to do. And but I think that came out pretty well. Now I want to show you something else. Give Chris credit for being there. So after the sun rises over on this side, it gets above the horizon and there's no more images to take. Then I diverted, and you see the people down here. This is Chris Dombrowski over here looking at the shadow. This is his wife over here, Maya. And so Maya and I were over at the sunrise thing. Chris was setting up down here, and then we sort of made our way across the hilltop. And so I'm on this big prominence looking down at them. And what is happening in this particular landscape is there's all these rocks forming. We call it the runway. Don't know a lot about how it happened, when it happened, but we do know that there are other glyphs, there are other rock arrangements, there are other things in this particular site. Sears Point is very active. I didn't mention it before, but as a petroglyph site, it has more concentration of petroglyphs than almost any place in America. And Evelyn knows more about those details, but 2,000 essentially glyphs in this acreage that is within these little buttes and mesa tops and all that stuff. So anyway, Chris and I wanted to find out if there's something meaningful at the bottom of this little runway, right? What is happening down here, especially at solstice, that has this particular look. And what we found is that it's I'm not going to call it a dud, but there is nothing, there's no interaction that happens in and around his camera here. You can actually see me on the top of this hill. This particular ridge right here is casting this particular shadow, and that little blob right there is me sitting there taking pictures from up above. Chris is actually taking pictures from down below, and what we find is that shadow is actually sort of moving off in this direction, and ultimately, went to a thank you very quickly, and ultimately it's going to sort of like end up over in here, and so this still sort of remains an object of interest. Indeed, from up here on the hill, you get this really beautiful, in fact, Chris probably has images of this, you get this beautiful view down across this through the runway and up to the sunrise over this particular peak, but it's still a little nebulous from us. We're not finding any just magical moment of this that's gonna make it work, but we tried. And that's really part of the thing I wanted to say here, is as much as we're using analytical data at the computer at home after all of our work, it still is not a substitute from being out there in the field. It still doesn't take away from going out and making the little sketch or being there on a hot day in southern Arizona, just kind of ready to look at the stuff and take images of the stuff. And so, we're not saying we're going to get to a point where we can replace the active engagement of people sort of dealing with these site surveys with this technology on site. And so that's kind of the wrap up of me. And then I sort of like created a little thank you today. So Chris sent me this image just today. So he's down below taking a picture of me up on the ridge line, and there I am. I think, what did you say, Chris? Is sort of like conducting the sunrise or something like that.
Yeah.
Shamaning the sunrise or whatever. So,
right.
So that's
I do have a time lapse from that camera.
Excellent. So anyway, so this is kind of the end of my major presentation, but I know Chris has more stuff to show us. Please, if anybody wants to weigh in, you have a suggestion, you want to talk any suggestions for the poster, any suggestions for how we, how we're capturing this, I think we would love to see it. So I'm going to leave you there.
I have a quick question on that last part there. Now, you said there was a PEC site which you think was the place of observation. How far is that from the rock?
It is only about, we should measure it, Chris, but I think it's 35 or 40 feet.
Oh, okay, so it's very close. Yeah.
I do have an image. I'll try to look at it while Chris is pulling up. I have an image of both the little rock site and the rock, just from the side angle, just to capture.
Right. Right. Well, I think this is really excellent stuff. In talking with Todd Bostwick years ago in Phoenix, he brought up a point that I've relied on in my rock art solar markers, and that is a place of observation, is defining that. And I know that Clive Ruggles talks a little bit about, especially out there in Arizona, New Mexico, when the view shield is hundreds of kilometers or, significant, then tying the actual place of observation down isn't as important, because regardless of how you move, but the closer the horizon gets to the place of observation, just a lateral step of a couple of feet could completely change the point that the sun rises. Yes. And so, you don't want to get into a situation where you seek and find exactly what you want to show, which may not be actually what it is. So you move to a position that gives you that aha, sunrise point.
I can make that work.
Yeah.
If
So
I just
anyway,
move over here, it's going to look great. No,
yeah,
you're absolutely right. And again, I have two comments about that because in this particular case, you saw how that rock and the sun sort of were just
yeah,
next to each other. Yes, indeed, if I had set up the camera like 3 feet over that way, the point of the rock would touch the sun. I mean, it's that close. But then in that other picture, I was showing you the winter one where Chris and I were up there, and Chris took the picture of Mohawk Peak.
right,
I was doing exactly the same photography, but I was about 150 yards to the north. And so we
right,
had that arm. Mohawk Peak is about 20 miles away.
yeah,
And so from his place, it worked. The sun did hit that peak. From my location, only 150 yards away, it didn't. It was close, but it just missed the peak and slid down next to it instead of on
right,
it. So
right,
that sort of indicates that that rock or that particular location where he set up because of that natural or that man-made thing actually makes that moment happen more
right,
accurately than what I did. And so, but you're absolutely right. And all of that is measurable, right? I mean, if you can do the triangulation, so if you know
sure,
what
yeah,
it is, you sort of how much. And we like to think in terms of, like I was saying, about 10 arc minutes. You can take any given point and figure out, what 10. I was showing you Escalante Pueblo. Remember that? And
yeah,
so Greg asked, okay, what if you're at this end of the wall? What if you're at this end of the wall? I did the measurement. It works out to a little less than an arc second at that particular level out to Hesperus Peak. So it's
well, because you've got a lot of distance there, so
because you got a lot of exactly right.
Yeah.
But your comment is really correct and right on spot on. So
Yes, Bill.
In my part of the world, we have a lot of trees, a lot of trees. So it's pretty much impossible to take that kind of a horizon panorama and have it reflect, the landscape any more than a couple of 100 feet out. So my question is, have you used, and what are your thoughts about horizon programs like, hey, what's that, as compared to, the techniques that you use?
Good question. I've got two answers for you. So first, hey, what's that? I use it, but I use it as a preliminary, and that would be a pre-field work thing. We would do a hey, what's that analysis just to see, okay, we're going to have a lot of peaks, and it marks them, and so that's kind of cool. My experience with it though is a little bit mixed. So first of all, it doesn't go. I think it rounds up to the nearest degree. Except I have found a location where it actually will give more accurate than, but mostly at Sears Point, it only rounds up to a degree, and that's not close enough for us. And so it gives you an idea what the peak is, but it doesn't give you that. It also, it doesn't include things that are important. So in this particular case at Sears Point, Mohawk Peak doesn't show up as a point of interest in, hey, what's that? So there's peaks around it here. And so here's the one that becomes the most important peak to this particular place, and it just isn't there. And the same thing happened to us up in Jackson. So I did a, hey, what's that from that upper hilltop location. And it's giving me sort of a peak of interest at an interesting sightline, like a solstice event sightline. But again, there are peaks next to it on either side, and it doesn't show those at all. And so then I have to do some more forensics work to find out, what's that actually trying to point to. And so then it's pulling out the GIS and doing the thing. So anyway, then the second answer to that, and then I'll get back to you, is that the other option, and Chris can do this, he does it for us when he does it, you can do a drone shot. So you take up a drone and essentially do a panorama. You just need to know, of course, that offset. And so get above the tree line, and you can sort of like see what this horizon would look like if you didn't have trees in the way. If there's something of interest out there, then you can go zero in and do that in calculation through map software and things like that. So anyway, I'm sorry, didn't interrupt. Yep.
The other technique that I use is LiDAR to assess horizon elevations as well. But my question, and calibration is always an issue. But my question really goes to which do you find easier to use when it comes time to load a panorama into like Starry Night or Stellarium? Is Starry Night easier than Stellarium? Because loading a
Yeah.
program, loading a panorama into Stellarium is a challenge. I find it great.
So I have some experience with Stellarium, but many years ago. And so it was my software of choice at a time in my career and all that stuff. I got interested in Starry Night Pro only because academically we used that at ASU. I'm now retired from ASU, but we used it. And we used it in a portable planetarium. So I was outreach. So I was taking this out to rural areas and boys clubs and all that stuff. And Starry Night Pro is the thing. So I learned its technology, and I learned how to use it, and I learned all the pieces to it, and so that became the natural one for me to do here. You do have to, in this case, go in and write essentially code. You have to change code and that kind of stuff to do it. It's a bit of a hassle at first, but once I figured out exactly those adjustments I needed to make in code to do this, I can actually literally get a peak with just right down to the minutes of a location in Starry Night Pro. Just by sort of doing, and I haven't tried that in Stellarium, but I'm going to learn a little bit more about. And I know Stellarium has improved a lot over the last 5-6 years. They all do. So I'll find out. And Gordon, I'll have maybe a little bit more experience in both, or William, a little bit more experience in both, and kind of help with that.
What about Peak Finder for horizon elevations?
Yeah.
Have you used that?
Yes, and it actually does have a lot more peaks. And is that the one? That one's written by hiking avocationalists, right? I mean, it's people that just go out and collect peaks. They go, yeah. I found that one, and it's especially relevant to southern Arizona. All of those peaks around Sears Point, that's really great. And you can bet that those guys, they're engineers and they're technical, and they're using the best device they have to sort of measure that location, that peak. And so yes, I have found that one. I like that one.
So going back to LiDAR, I found with some trial and experimentation that I can take a LiDAR image and cut and paste, basically, not embedded into Stellarium as you would probably, but if I cut and paste, I can pretty much generate or paste a profile, a horizon profile into a Stellarium, and it seems to work okay as long as the lateral angles are calibrated correctly.
Yeah. What Chris and I are doing out at Sears Point, and I find this part of what our process really exciting, is we're testing those things, right? What can I at home predict and then go confirm in the field, and then what kinds of things can we find in the field and then go sort of retrodict by using softwares and all of that kind of stuff. And so we're all a little bit amateur at this, and I think there's experts that know a lot more about that.
Say something about the LiDAR real quick?
Yeah, so a real good example of not getting this right is Chris and I were interested in, that feature I showed you at the very end there, where Chris is down below, sort of like taking the image up, I'm on top of the thing. We tried to sort of get the elevation difference right between his point and my point, off-site or offline, using all kinds of different softwares, from Google Earth to this kind of stuff, and we could never get it right. Once we did that particular observation the other day, just a couple of days ago, I went out after that picture taking session and walked the transit all the way out to that location and nailed essentially that particular peak, just sort of like exactly where it is, and then predicted the sunrise, and it was very close to what we discovered. Now, I understand that's a little bit like telling you what the score of the basketball game is after the basketball game's over. We're not predicting anything that way, but we did. Sometimes we have to go backwards and say, okay, what would we have to have known to actually predict this correctly, and why is our software failing at this particular point? Chris, I'm sorry, you had a point too.
Oh, exactly to that peak. So at Sears Point, it's a very sharp it juts out. It's very, very sharp and well defined. I don't know if you showed that picture earlier, but it's very sharp. And the reason we were interested in it is if you use the LiDAR data, like in Google Earth, it's a much bigger, it gets kind of smeared out. And so if you look at where the sun comes up on the LiDAR data, it's kind of very prominent right in the middle. And then when you have the actual profile that we go out and measure, which is beyond the resolution of the LiDAR, you get a much more realistic, and you see it's not where you thought it was.
Well, Chris, when you say beyond the resolution of the LiDAR, what LiDAR are you talking about? Are we talking about USGS? You know,
I
uh,
I'd
LiDAR
have to
data,
look at
or
the layer, but a few meters, right? So
It's 1 meter
okay, so
resolution.
so at Cahokia, what we did was we flew a LiDAR
okay,
drone.
Oh
right,
yeah,
yeah.
yeah, a better
So I
resolution.
mean that I'm just saying that's always an
So
option.
Oh yeah.
no, yeah, exactly. So, but it's the same idea. You have to go out and get your own data at some point because
Right,
what,
right, right,
what
right.
you're going, and I think it gets to your point about the horizon too, because if it's a big feature way out, low resolution LiDAR is fine. But as you get closer and closer to that feature, you
Right.
really need to know where those lines are in a
Yep.
much higher resolution.
Yep. Exactly. Well, that's part of the fun, right?
Yep.
It absolutely is.
Now,
And
I have another question.
Yeah.
I noticed on your form, your recording form, you had magnetic declination. And so how do you address that? Is that strictly when you're using magnetic compass in your initial surveys?
right.
Because, obviously large stone, mountain structures can give you a declination that isn't really in the chart, so to speak. So, but that's strictly, so you're just using that for magnetic initial survey.
Yeah, well, it depends on the instrument you're using, and we always record the magnetic declination. Um, if the instruments are corrected, or if we are typically what we'll do is we'll start with a reference peak where we know what the azimuth and elevation of it is, the
Right.
azimuth of it is, so we could set and then go from there. Um,
Well, are you doing
or
any?
in cases where we don't have reference peaks, we could use the theodolite and determine the declination.
Right. So you're doing some sun sites with the theodolite, right?
Right.
Yeah. Okay.
We did that
So
at the hilltop site at Jackson's Castle, and it just went dead nuts. Perfect.
yeah. So we
Okay.
actually are of different minds about sort of the accuracy of a compass, and so Chris and I sort of think about it two different ways, and so but we agree to sort of like disagree about it. My thing is the compasses I have allow you to adjust the declination before you go out, right? And so then you sort of just have to set right the thing, and so what you're measuring is a declination corrected true north. Chris is of the, and don't let me put words in your mouth, Chris, but he's of the sort of measure what you measure, just mark it as magnetic, and then go, kind of do the translations at home. And
Right.
so we're sort of both ways about this. But I just have turned over, we had it prepared for Jackson, but I used it here the other day in Sears Point, is the sun site. And what I do is I create a table in advance off of the JPL Horizons program, and I essentially have a sun declination every minute for the entire morning. And so then when I set up the thing, I sort of align the sun in my transit. I look at the time, I look at the chart, I know exactly where that declination is. I set that on the transit, and then that becomes my starting point.
Right.
And so I think that's probably, I have to believe that's the most accurate way to get that job done. It seems like it. So
Yeah, well, both methods have their uses depending on the situation. If you don't have the sun out, you've got to be able to
also remember in my
have other ways
presentation,
of doing it when you're in the field. So there's a multiple
yeah,
technologies and ways of doing it.
and
They
my
just have to
presentation, remember,
be
started with actually doing a little sketch and using a compass reading to sort of like just measure it real quick
right.
and find the peaks of interest and get at least a zone, and that kind of stuff. Chris, admittedly, is remarkably good at using a compass, and so I think I'm plus or minus half a degree. I think he's probably plus or minus a fraction of a degree. He's a lot better at it than I am.
You can get down to about a quarter with his sun toe, yeah.
So this is
Still has a comment.
I'm sorry. Let me just introduce the image, and then I'll go back. This is from you, Chris. So this is essentially that shadow image. So I'm at the top of that little peak, taking images back. The shadow is still in place. You can see Chris's camera set up kind of this is where he was.
Yeah.
And so now he's uphill a little bit, aligning the runway with where that sun would hit that peak. And so,
And
finding
I think there's a really good point to be made here. There's not an obvious place to be at the end of that runway. So I set the camera up kind of right at the base of it, but then we were walking. I mean, there just isn't an obvious observation point.
We wanted to see like a stand here, arrows, some sort of monument or marker. So stand
Well,
here. And
what is the distance from your camera to the peak?
It's 230 something feet.
So see, that's
That's still pretty close. So
It's still
position
close.
matters.
yeah. But I mean, with that avenue, looks. I mean, that certainly looks man-made to me.
It's very compelling. Yes.
Yeah, it's very compelling.
Oh, it's definitely man-made, but I don't know if this is some sort of thing that a bunch of Boy Scouts did like in the 20s.
No.
Or
Yeah, well,
but there's many examples up here. And actually, I'm not the expert on this. Evelyn has spent a lot of time up there. Chris has been there a lot. But there's many examples of worked stone, hex stone, marked stone, placed stone. I mean, it just happens over and over again. So investigating it like this was definitely a worthy cause. So
There are many.
yeah, go ahead, Bill.
That infographic slides that you showed, I'm not familiar with that program. Is that an AI program? I didn't understand what that was.
So what I use, it's the other AI. I use Adobe Illustrator, the original AI. And I use it because it has, it's all calculable, right? So you're not actually drawing, you're actually using numbers. So I have a preset. Here's how big my rings are. Here's how I make the arcs. Here's how I set all of those angles. And it takes a little bit because you have to work it for every latitude. But, once you sort of get to do it a couple of times, it works out okay. And I'm using the same kind of little, what's that?
You know what that is?
Looks like a Brunton compass.
That is a Brunton. No, that's a Francis Barker M73, probably the best handheld compass in the world.
Nice.
Right? Yeah.
Hey, can I borrow that?
Yeah, sure.
Send it to us. Yeah, we'll take it.
You got it, man.
Send it to me. I'll take it on our next field visit.
It's my favorite.
And obviously it works for you, right? I mean, it's not like
It's my favorite. So hey, that's a great photo. That's a keeper.
Yeah,
that's a keeper. Yeah.
No, there's something going on here.
Yeah, it's and Chris and I both love this place because just a little personal stuff, but Chris lives in the Bay Area but his parents are in Yuma, so he travels there a lot. And this is, what would you say, Chris, about an hour and 15 minutes from home?
About an hour and a half out of Yuma.
So I'm actually in Phoenix, and so this is about 2 hours and 10 minutes for me, but that's not bad. You've got to go through Gila Bend and over. And but this is what we try. I mean, it's you can park close enough that you can carry equipment in. We can kind of conceive of an effort like, we want to try this, or we want to measure this, or whatever, and we can kind of organize to do it and just meet out there and kind of like do this thing. And so I think we're sort of using it as a test bed, because everything we're learning about here about the accuracy of GIS, or the error bars within all of these different programs and how they work, we can kind of test it here and sort of like work out those problems. And anyway, so that's why I kind of like this place. And
so I posted it in the chat, but you might find this new article that I wrote posted in the Journal of Astronomy and Culture interesting, as I show at least 14 or 15 different handheld compasses and transits and so on.
Oh, excellent! I would love to see that. Oh, yeah.
Yeah. So it's posted. It's up on the JAC website.
Okay.
So enjoy it.
Yeah, I will. That'll be what I read on my plane to Australia.
Could be, yeah. And it's going to be interesting when we do go to Australia, because we will have the opportunity to work with Georg Ziadi with Stellarium and see how to do this and expose him to what we're doing too.
He's the Stellarium promoter, and I'm not saying anything bad about it. I just know from my My personal experience, yes, used it, and I found it kind of hard to work with in some areas. And then I just happened to have this other one, and it made more sense to me. So, but I could easily be convinced that another one is better than this. But I really do like Starry Night Pro, what it does, and it
Well, I sure
works
wish
for us.
I sure wish I was going to Australia with you guys. Man,
Me
that's
too.
going to be a great trip.
I don't think it's
I don't know
too
if they've
late.
closed it, but I'm registered to as an online participant,
Oh,
so I'm not
Yeah.
going, but I'm going to see how watching everything from my own desk like this.
Yeah, good.
So,
Oh, I didn't know that
I
was
got
available.
the list. I
Yeah,
didn't see you on
they're
it, but
doing
I
a-
wasn't looking for.
I didn't
Oh,
know that
yeah,
was an option. That's great. I'm going to do that as well.
what?
yeah. So, and
No,
the
I think
timing's pretty
the
good.
online viewership is. I don't know if registration. I don't know if registration is closed for that for the
No.
online.
Yeah,
It was
it
like
might be. Yeah,
$100 to
I
go
think
online.
everything's closed. Yeah, but it was only like $58 or something to register
yeah,
for the
that's
conference.
Pardon.
Ours
Just
is
send Chris
costing
the link.
Do what?
Ours
Just
is
send Chris the
costing
link.
ours is only costing $4,500. So
Right.
Yeah.
hey, Chris,
the,
do you have? Chris, do you have the sketch I did in that I sent you the other day? I can't find it.
Give me 1 second. Hold on, pull it up. And I think Evelyn was going to say something.
I'm
She's
sorry,
the
Evelyn.
expert
I keep
on,
stepping on you.
I was
good
gonna.
point.
I forgot. Oh, it was about when you had the what you were calling, I forget, the racetrack or something. Where you
Runway.
guys were standing was an archaeological feature, and I'd have to go look up because I did the research a whole long time ago, specifically what it was. But there, the scenery has changed. The elevation would have changed down there if it is a depressed pueblo, and it could. So there's lots of things to consider because that's a
Yeah,
That
and
would be
that's
great. We'd love to see it because then we can actually take that and translate it because Chris has given us some really great orthorectified, kind of images that I'm still working with to try to just sort of match up and geo-reference into a GIS program. But we could take, Evelyn, your work and actually put it in there as well, or your sort of notes, and that would be really cool to look at. I think that would be great.
well, and as I think Chris was the one anyway, knows I have like 4 or 5 boxes of Tom Hoskinson's memos and photographs, and it's not all from Sears Point. It's all his work. His family sent it to me. We thought there was going to be an archive with ARARA, the American Rock Art Research Association, but that hasn't happened. And so I don't know if are we still at SCAAS planning to have a library or some sort of archive?
we're working through it, unfortunately, very slowly, but we are working through an archival program. It's we're focusing on the cultural sensitivities part, and we have to get have all the rules in place and all the buy-ins, and so it's becoming a much bigger project than we thought, but we're still more committed than ever that it's a necessary thing. We all of us are doing such great work, and then it just sort of disappears, and so we really need to figure out a solution for our community as a whole for this.
So
And I was going to email you, Evelyn, and I'll talk to you offline, but I'm hoping to stop by after Pecos, or if you're going to Pecos, that'd be great. We could talk about it then.
Maybe. Bob just got a brand new knee.
Oh, that's
3
right.
weeks ago.
Oh yeah.
So if he's doing great, they said at the physical therapy today he was actually at a 6-week level. So
Okay.
I'm hoping maybe we'll make it, but
That's great. Oh, we'd love to see you, Evelyn.
That'd be great. Yeah.
Yeah, I'd love to come.
Okay.
So let me just tell you what you're looking at on the screen. This is sort of what I was kind of joking about is, knowing the score of the basketball game after it's over. But this is then after we took all those images where you saw Chris down below me, up above all that stuff. I took a transit out and I really nailed that peak, just exactly what its altitude and azimuth is, and using the sun site to organize it anyway, all that stuff. And then these particular locations of the sun, it's like every 3 minutes, I pulled out of JPL Horizons. I don't know if you know that thing, but that's that one I use, and it just gives me the altitude and azimuth of the sun from that location. And so I was able to just draw it in like this. Now, what we haven't done yet, because this is all new news, and Chris was just driving home yesterday, is I want to go back and look at Chris's metadata from the images he took from that camera, just to see how close we are on this timing. Because I think, Chris, you'll agree this is about the path of the sun is right.
Yeah.
But
Yeah,
I
that looks
wonder
great.
if we also were able to nail the times, which isn't as important, but it would be
Right.
cool to see if that works.
Well, that's one of those. I don't know if you had the horizon elevation in any of your recording there. As from your place of observation, what the the horizon elevation is for atmospheric refraction and or scattering.
Gordon, it's an issue, and it's another relationship with Starry Night Pro and Stellarium. We'll find out how it does that, because
Right.
they handle refraction differently. And then there's also the calculation of dip, right? I mean, the distance. In fact, Mohawk Peak, I calculated it out. The Mohawk Peak is a little less than half a degree lower on the horizon because of the curvature of the Earth and the distance.
Right.
And so you have to. Now, the planetarium programs aren't going to do that, right?
Right.
So you have to do that yourself. Then in Starry Night Pro, I think they cheat a little bit. What they do is they just make the lower degree between 0 and 1 of half a degree longer than the rest of them. They just know at that particular horizon. They literally in their program, they just expand that degree marker a little bit, and they call that a refraction offset. But in JPL horizons, they also account for refraction. You can turn it on and off. Do you want it or do you not want it?
Right.
I haven't taken the time, and I'll have to do this because I think it's meaningful, is to see if it's on or off, how closely it matches a planetarium program, right? Is a planetarium program showing? And I actually don't know the answer to that, but it's kind of on my list of geeky things to do.
Yeah.
So,
well, that'd be good to, supporting evidence, for the overall program. So
yeah, and the one what I was pleased about in the one I was showing you from Sears Point, I did all of those calculations for Mohawk, but it was the same panorama that I used to do the predictive thing for the summer solstice one. And it was able to capture that particular elevation of the horizon line accurately. So once you have sort of landed that horizon, it's very important to get the panorama horizon exactly right, up and down and right, all that kind of stuff. Once done, it translates into those programs as near as I can observe very, very accurately.
Right.
But you can imagine it would be easy to have it off this way, where you nail the western horizon and the eastern is all wacko. I mean, you can imagine that wouldn't happen.
Yeah.
Yes. Yeah, William.
My preference has always been to do the calculations by hand, take refraction into account, and semi-diameter and so on and so forth, and then once I have the numbers calculated by hand, then I'll use Stellarium to sort of like to test what I've worked out. And if it's close, great. But I don't rely on Stellarium first. Rather, I rely really on the calculations by hand as my primary set of information. Yeah, Stellarium is nice, but I don't rely on it as gospel because of the refraction and other issues.
My go-to for accuracy is the JPL horizons, which doesn't show you imagery. I mean, all it is tables. Sure. And I have to believe, I guess if you're going to find something accurate, that should be the one. But I'm sure, maybe there's errors in there too. But this sort of brings up a little bit of a point. And when when Greg and I are in Australia, I would love to sort of like identify like an international little user group that just kind of deals with these little sort of just technical issues. Like you wrote a whole paper on whatever, various compasses and transits and all that kind of stuff. There's people around the world working on the same thing, but we're not really talking to each other. And so what is that best practice, and what is how to double check it and all that stuff. I also write a lot of those calculative programs in Excel. I just basically, basically write the program. It's kind of by hand, but Excel does the math. And so I created little things where I say, peak here at this elevation, I'm here at this elevation, known distance, and then I sort of like use the thing to calculate, what's the drop and what's the refraction and all that stuff. So, yeah.
Well, we would need a conference about probably a week-long conference, at a central location where we could bring everybody together.
Small pieces. I think we just do.
After a week of that,
take one of these things.
I don't think you'd agree.
yeah, but so there's been a lot of work has happened in Europe. I mean, they're maybe even a little bit 6 years, 8 years earlier,
ahead of us.
And they're definitely geeky. But what I've read in papers and things like that is, of course, they're dealing with monuments like classical Rome and Greek and temples and things like that. And we're obviously dealing with a different set of things, but some of the stuff works, and they're using LiDAR a lot. We haven't, I think we decided we don't want to afford LiDAR. Is that what we've decided, Chris?
That's very expensive.
Our own little, our own
little
LiDAR thing. I'm not sure we're there yet. We need bigger grants.
Bigger grants, yes.
Yes, before we sort of get there. But so we're trying it without.
Thanks, Rick. That was really good. I really enjoyed that.
Oh, Bill, thank you. And thank you, Gordon.
Everybody.
You can tell this kind of charges me up. And we've been working so hard, concentrating on this so much.
Right.
It's all top of mind right now. So I'm gushing with things to talk about. So,
well, how are they going to let you? How are they going to let you present the poster? Is it just going to be a stand around thing and people look at it?
I heard we got the program recently, and they have these inside the 10th floor of the law building at the University of Melbourne is these large glass walls.
Right.
And they're have us put our posters up on the glass walls.
We're using blue sticky putty,
plastic tack, to stick it up on the wall.
So we applied for a talk, but actually I like
a lot of people I know got posterized because they had just too many talks.
Yeah, and I think I'd like it better after I sort of heard it, because
too.
Mary actually, Mary Rocky, you've met her. I think she has a talk, so it's sort of like we're in front of people. That'll be kind of cool. But I think we can talk a lot more at a poster. I think, and the people that are really interested are going to come up and they're going to ask the questions. They're going to engage,
right,
rather than talking to 80 empty faces, right? And so after I kind of thought about it, I thought, this might be for our particular purposes a better way to do this and engage people. So we'll see.
Yeah. I have two quick questions for William. Have you written anything on Cahokia? Any kind of horizon work on that? And now I know on my Brunton compass you can also take elevations, and I searched around hard on the internet years ago, and I've got a Brunton non-magnetic tripod for it. It's really
Okay, so my answer is this. I have the Brunton non-magnetic tripod. I included in this article that I've referenced in the chat section, and I have 2 or 3 articles currently out about Cahokia. I think at least one of them is on the JAC website. The other one just came out in the Mid-Continental Journal of Archaeology, and that's where I used high-resolution LiDAR to assess astronomical alignments at Cahokia. The current one that's available on the JAC website is easy to access. I mean, it takes you like 2 minutes to navigate to the site and just scroll on down. And there's another article that you might find of interest about the St. Louis Mound Group right across the river. And this, my friend, is not a Brunton. This is a Barker. This is a Francis Barker compass made in 1973. It's the M73 model. It's supposed to be it's very outstanding compass, and a lot of people have said that it's the best handheld compass in the world. But whatever. This is another one. Show and tell time. This is another prismatic compass, and this one is also by, you can see that, by Francis Barker, made in the 1930s. But a lot of these old compasses are really very useful in the field. A lot better than the Sunto and Brunton stuff that's made today. But anyway, you'll find that compass article of interest if you're into compasses and transits and things of that sort of brother.
Yeah, that's why I asked. Yeah, I'd like to see that. Yeah.
Okay, cool. What I need to do is we're running long on the recording, so we can continue in the after party here, but I need to stop the recording so we can get it uploaded. So thanks for coming, everybody, and we'll be chatting again soon.